So here we have the dimer question that was in the exam. Suggest how benzoic acid, molecular weight 122.13, forms an apparent dimer, which I don't know what that is, molecular weight 244.26 when dissolved in a non-polar solvent such as hexane. So I have to dissect that question a little bit. So we will draw out. So there must be a 6 carbon. So that's a hexene with a ring. So it's benzene. So draw that out and draw out all the carbons. And then add the carboxyl group in there. So there's a double bond O with an OH. Draw that in like that. So this one will have a permanent dipole pos. That one will have a neg one there. There is 2 lone pair electrons on that oxygen as well. Draw out all the hydrogens. Just to double check that the benzoic acid is actually 122. You could probably skip that bit. This is only worth 1 mark, by the way. And there's a heck of a lot of stuff going on in this question, as the title suggests. So 7 carbons, so carbon's 12. So again, you could probably just skip this step. So that's 84 oxygen, oxygen's about 16, so that's 32. And then count up the hydrogens. 1, 2, 3, 4, 5, 6. And so there's 6. Add all those together. It's about 122. We've done some rounding there. And so double 122 is 244, so that's about right. So it is 2 of them. So you have to work out how they join together. So that's what the word dimer must mean. It must mean 2. So even though that's not in the core syllabus, you've got to kind of suss that out. Okay, so you've got hexane there as well. You've got my daughter deciding to play the piano. But that's just too bad, I'm afraid, because I'm not going to start again because a plane just went by earlier on, and this is my 2nd time around explaining this one. So you'll have to deal with that, I'm sorry. I'll try and decrease the sound. Okay, so there's a proper way to write the delocalized hydrogens over there with that dotted circle. So I'm going to put and just do the shortcut here for the 2nd molecule, draw that in, show you how the negatives and positives could link up, and where the hydrogen bonding is. So hydrogen bonding technically is the hydrogen, which has to be bound to an NO or F, and then that hydrogen bonds to a lone pair. So that COO bond, so C double bond O, has 2 lone pair electrons. And just double check drawing out hexane. You can see hexane looks as it does there, and there is no pole, so it's a non-polar. Okay, so that makes the most sense. There's a trigonal planar shape in there, so I've drawn it out approximately in the right steric shape, so you can see that it fits together nicely like a puzzle. And so it says suggest, so I'm putting suggestion. So as benzoic acid contains, I'm going to speed that up a little bit, as contains hydrogen bound to oxygen, it can form hydrogen bonds. The structure of benzoic acid has a steric arrangement that lines up the negative O in the COO bond with the positive hydrogen in the hydroxyl bond, OH, hexane solvent, and the other parts of the molecule are non-polar, providing only London dispersion forces. So that's sort of my explanation. And so these non-London dispersion forces are not strong enough. And so it's only the hydrogen bonds that will link together to form this molecule, this dimer. Okay, if you go to the marking scheme will just say hydrogen bonding. And they will accept that diagram. But in this case, they won't accept the diagram because the diagram is on the outside of the box, and you would have had to have drawn it on the inside of the box for it to count. Good news is all you had to write was H bonding, or H bonds perhaps. That's H bonds, B-O-N-D-S. That's 5 letters, B-O-N-D-S, 6 letters. And you would have got a mark for that. But look at all the work that goes behind getting that mark. I'm pretty sure In a lot of other syllabuses, this would be worth 5 marks. ATAR chemistry. But in IB, this is a standard level question, by the way. It's in the high level paper as well. This is only worth 1 mark. Okay, welcome to IB.